Hello everyone, it's Salar and welcome back to the Rtos tutorial. This is an update part, okay? And since now we will have some update parts, okay? And when I add some features to the Rtos, I will create some update parts to teach those features, okay? But for the first updating part, in this part I want to talk about system call from interrupt. Okay, system call from interrupt. As you know, for example, in Rtos, in our Rtos, for example, in source directory and in semaphore. For example, in one of system calls, for example, semaphore release, you can't call system calls from interrupt, okay? And if you call system calls from interrupt, you will have an error in return value, okay? Error or null value, okay? So, but sometimes we need to have a system call from interrupts, okay? But why do we need to use system call from interrupt? Okay, it's the question. Why do we need to have system call from interrupts? Let's see an example. Another time, consider this example. In this example, for example, assume that you have a processor in your car, and this processor with these 4 threads controls your car. For example, in thread 1, check and monitor the heat of the engine, okay? In thread 2, read and monitor the speed of car. In thread 3, monitor the fuel. And thread 4, this processor control ABS brake in your car. And as I said in previous parts, some threads has higher priority. For example, ABS brake in our car has higher priority than others, okay, than others. But assume the thread in a normal situation suspended, okay, in normal situation suspended, and when you push the brake in your car, you will have an interrupt, okay? And in this interrupt, you want immediately active the thread and resume thread 4, okay? In interrupt, you want to resume thread 4, okay? In this situation and in this condition, you need to have system call from interrupt facility, okay? For example, in this example, by an interrupt, when you push the brake, you have an interrupt, and in this interrupt you want to resume thread 4 immediately, okay? So you need to have system call from interrupt facility. So let's talk about system call from interrupt. Calling a system call from interrupt has some problems, okay, has some problems. But what are these problems? Let's see what are these problems. First, in our Rtos, interrupts have higher priority than SVC and kernel. As I said, PendSV priority is number of priority minus 1. For example, if the number of priority is 16, the PendSV priority is 16 minus 1 is equal to 15, okay? SVC is 16 minus 2, for example, is 14. At the top, systematic priority is 0, okay? And between systematic and SVC, you have interrupt priorities, okay? Other interrupt priorities. For example, assume your external interrupt priority equal to 10, okay? The number of priority is smaller than SVC, so it has higher priority, okay? So in our Rtos, interrupts have higher priority than SVC, and we can't call SVC 0, for example, call this instruction from an interrupt with higher priority, okay? For example, here, when you want to have an interrupt, you need to call kernel system call, and in this function, processor call SVC. But if you call, for example, semaphore resume from interrupt, this function called from an interrupt with higher priority than SVC, and in this function you can't call SVC, okay? So in our Rtos, interrupts have higher priority than SVC, and we can't call SVC from interrupt with higher priority. This is the first problem. How can we get rid of this problem? By using of pendSV. If you want to call SVC from an interrupt, first you want to call pendSV, and in pendSV call SVC, okay? I will implement this part. I will implement this option in next part, okay? So to get rid of this problem, first you must call pendSV. When you call a system call from interrupt, first you must call pendSV, and after that in pendSV call SVC, okay? But the next problem, to support system call from interrupt, we must change this function kernel system call handler. You know, in kernel.c, you know, in kernel.c we have this function kernel system call handler, and this function read system call list elements and run each of system calls in this list, okay? By using of this code, run all of system calls in the system call list, system call requests in system call list, okay? But we need to change this function to support interrupt and system call from interrupt, okay? You know, now this is the implementation of function, okay? This is the implementation of function read index. After that, in this for loop, run all of system call request in system call list, okay? This code. But we need to change this code. Why we need to change this code? Let's do describe, and let's do say you why do we need to change this code. Consider this example. Assume you have two arguments in system call list. You have two system call requests in this list, okay? And assume index is 1. Index equal to 1, okay? First, this function read index equal to 1, and after that it wants to serve these system calls in this for loop, okay? But assume after reading the index you have an interrupt, And in this interrupt, you have a system call. You have a system call from interrupt in this interrupt. And this interrupt wants to write its system call request, its argument here. A, for example, to from interrupt, okay? And change index to 2, okay? But this code have read the index, and the number of index is 1 until here. And this for loop runs and serves just these 2 system call requests, okay? And will not serve this request from interrupt, okay? Because interrupt has higher priority than SVC, and interrupt wants to have a system call, its argument from system call from interrupt, and this interrupt changed the value of index in kernel control block, but in this local variable index is 1, okay? And this for loop will not serve this request in system call list. So we need to change this function. We need to replace this code by this code, okay? By this code. Another time, assume you have A0 and A1 request in system call list, okay? And index another time equal to 1. First, in this while loop, with an read exclusive function, this function start an atomic part, okay? Start an atomic part from here and read the index. Index is 1, but assume after reading an index you have an interrupt, and in this interrupt you have a system call, and argument is here and index change to number 2, okay? Because this is an atomic part in this write exclusive function, this function doesn't write the value of null in system call list, okay? And another time run while loop from the first line, another time run index, but in this time index is equal to number 2, and at this time this function can run this request, can serve this request, okay? If index greater than 0, index is 2, and if list system call list index here, system call list 2 is not null, give this value argument 2 and write null here. And if write is successful, call kernel system call by number and run this system call, okay? And after that, another time return to the start a while loop, another time read index, another time read index, another time index is equal to number 2. Index is greater than 0, but list.index equal to null. Run this part to decrease the value of index, okay? Decrease the value of index another time to 1, okay? Another time the value of index is 1, and another time run the while loop, but in this time index is 1, index is greater than 0, but index 1 is not null, is this argument, serve this argument, serve this system call. And after serving all of system calls by using of this part, this else part, onset system call handler request. This is a member in kernel system call. Unset this value and breach while loop. Okay, by using of this code you can have a system call from interrupt service. In next part I will replace this part of code by this part, okay, to support system call from interrupt. So this is the first problem. You can't call SVC from interrupt. To get rid of that, first you must call pendSV, and after that in pendSV call SVC. The next problem, you must change this function body, okay, change to this code, okay. But the last problem in the kernel, here there is another problem, and the last problem in the kernel. There is another problem. You can't send argument from user space system call function to kernel by means of local variables. What is local variables? Let's see what is local variables. For example, here is an user space system call, for example, another time is semaphore and semaphore release. Semaphore release is a user space system call function. And when you want to send an argument from user space system call function to kernel, you use these two structures, specific structure and global structure. These local variables. These are local variables, okay? You can see global structure and a specific structure defined in this function and is a local variable, okay? But you can't send arguments, for example ID or system call number arguments from user space system call function to kernel by means of local variable. For example, you send this argument by using of this local variable to the kernel space system call. But why can't we send arguments by using of these local variables? Let's describe that. This is the reason. Let's inspect this reason. Because user space system call from interrupt runs in higher priority than SVC. Okay. Assume you want to run this user space system call from interrupt. At this time, ignore this part, okay? Ignore this part and assume you can run this function from interrupt, okay? When you call this function user space system call from interrupt, this function has been run in higher priority than SVC, okay? When you run this function from interrupt, this function has been run from a higher interrupt than SVC, higher priority than SVC. So this function called from interrupt, and when you use these local variables, you want to send, for example, ID to this kernel space system call, and for example, you want to send the system call number to the kernel, and this function kernel space system call and other functions of kernel will run in SVC priority, in SVC exception. Okay, when you put these values in these local variables, After that, you want to jump to SVC by using of this function. Okay, if you run this function from thread space at this function, before returning from this function, the operating system jump to kernel. At this function, jump to kernel, serve the system call, after that return from this function, and after that return from user space system call. But when you call this system call from interrupt, at this function, processor doesn't jump to kernel space because this function has higher priority, has been run in higher priority. First, processor return from this function and return from interrupt, and after that jump to kernel space and SVC. Okay, first return first return from this function, and after that serve kernel space system call, and after that serve SVC exception. And when you return from a function, you will not have your local variables anymore. Okay, when processor return from a function, processor will remove a stack frame of this function, and you know these variables located in a stack frame, and after returning from this function, you will not have this variable in memory and in a stack anymore. Okay, so by using a local variable, you can send your argument to the kernel space, because at this function, in this function, the processor doesn't jump to SVC. First return from this function, and after that return from interrupt service routine. After returning from interrupt service routine, jump to SVC. Okay, supervisor handler, SVC handler. And by returning from this function, you will not have your local variables anymore. So let's another time read this slide. Because user space system call from interrupt runs in higher priority than SVC, higher priority than SVC. And before running of kernel space system call, processor returns from user space system call. Before running of kernel space system call and other kernel's function, processor returns from user space system call. Because this function has been run in higher priority, before running kernel space system call and other kernel's function, first return from user space system call. Because of this reason, and remove user space system call a stack frame. A stack frame, you know, local variables located in a stack frame. And removing user space system call a stack frame, you can't use local variable, a specific structure and global structure to send arguments. Okay, you can't send argument from user space system call to kernel by means of local variables in user space system call. Okay, local variables of user space system call. But how can we get rid of the last problem? By using of interrupt request array. This is an array in heap. Okay, in next part I will implement and locate this array in heap as a global memory, and to call a system call from interrupt, we will use this array to send argument. I will say in the next part how you can use this global array to send your argument to the kernel. So you must send system call arguments to the kernel by using of system call array when you want to call a system call from interrupt. Okay. You must put arguments, system call number, and other informations instead of local variables in interrupt request array to send to the kernel. But in next part I will implement this array. Okay, so we have three problems when we want to call a system call from interrupts. First, interrupt has higher priority than SVC. To get rid of that, first we must call pendency, after that call SVC. We need to change the body of this function, kernel system call handler, and implement this function by using of this code, this atomic part. And after that, to send argument to the kernel, we must use this array, this global array. Okay? But in next part, I will implement semaphore release and semaphore get from interrupt. At this version, you can't call semaphore get from interrupt, and if you call this function from interrupt, you will have an error in return value. But in next part, I will change this function and the system call to support system call from interrupt, and I will talk about implementation issues. Okay, so in next part we will have two system call from interrupt functions, semaphore get and semaphore release. Okay, so very good and very nice. Thank you very much to see me, and see you soon in the next part, another updating part. Thank you very much.